Now we are like in a position to write the order of the energies according to the increasing energies, because now we are going to write the electronic configuration for a molecular orbital. So when we are going to write the configuration for the molecular orbital, we need to know the order of the this thing increasing energies. So first look at the order, then I will tell you how to draw in a molecular orbital diagram for a molecule. So the order of the energies is sigma 1s, sigma star 1s. As you all know that for each orbital, bonding molecular orbital is going to possess less energy and anti-bonding is going to possess high energy, right. So this is 1s orbital, sigma 1s with the lower energy and sigma star 1s with high energy. Likewise, we have sigma 2s, sigma star 2s, sigma 2pz, pi 2px equal to pi 2py. Now this must be striking that why I wrote pi 2px equal to pi 2py. Actually you know that 2px and 2py, the pi ones, they have the same energies. So that means that is why they are just indicated by putting a this thing equal to sign between. But when we talk of the anti-bonding, so what happens? The anti-bonding of pi 2px, both again possess the same energy, but their energy is actually less than the sigma 2pz, right, and sigma anti-bonding 2pz has the high energy. So this is my order actually of writing the electronic configuration for a molecule, that is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px equal to pi 2py, pi star 2px is equal to pi star 2py, and sigma star 2pz. So this is my order of increasing energies. Now we will be writing the electronic configuration, but before I will write, we get to see a few certain exception actually. So this kind of order is followed for few molecules, but for few molecules actually this order gets little changed. Now what is the change? I will just write here, sigma 1s remains sigma 1s, sigma star 1s remains sigma star 1s, sigma 2s remains sigma 2s, sigma star 2s again remains sigma 2s, but here what happens is this sigma 2pz gets shifted here, because for few molecules the sigma 2pz in energy actually increases, right. So that means the energy of pi 2px and pi 2py is comparatively less as compared to the sigma 2pz. Not for many molecules, there are the exceptions actually which follow this rule and which follow this rule, right. So what we have to write, here lies a difference, pi 2px is equal to pi 2py, now sigma 2pz, but the anti-bonding remains same, right, the anti-bonding remain as such, like this, right. So this is the order. Now you have to keep in mind like for which molecules we need to follow this order and for which molecule we need to use this order. The difference lies only in the places of these things, otherwise everything is same, right. So this is actually followed for O2, neon molecule, fluorine molecule, and for rest nitrogen, carbon and all, we follow this order, the second order, right. So actually this is the, you can say, order of increasing energies. Now we need to write the configuration for a molecule, right. Suppose I have a molecule, let's say O2, I have a molecule, let's say O2. Now how I have to write the configuration? I need to follow the same rules as we did for the atomic orbitals. So first what I am going to do is, I am just going to write the valence electron of oxygen, because here I have oxygen. So valence, the electrons for the oxygen is 8, total of electrons, not the valence electron, 8, and there are 2 oxygen, so total electrons comes out to be 16. So now I will be writing the electronic configuration for the 16 electrons, not for the 8, because the molecule is actually formed of 2 atoms, right. So start filling it. So what do you get when you fill it? Sigma 1s square, sigma star 1s square. Do not exceed the electrons above 2, you know that, because each orbital can occupy maximum of 2 electrons. That is why we are filling 2 electrons. Again 2s, sigma 2s square, sigma star 2s square. Now in oxygen we are following this rule, right. So that means sigma 2pz will come before. Now how many electrons are already filled? We'll count 2, 4, 6, 8 and 10. We are still left with 6 electrons. So we have 2px is equal to pi 2py, 10, 11, 12, 13, 14, and then I have, this is my anti-bonding. So the count again, 2, 4, 6, 8, 10, 11, 12, 13, 14. We are left with 2 electrons. But I am not going to fill it like this because they possess the same energy, and we know according to Hund's rule that the pairing of electron in the orbital with similar energy won't take place until and unless each orbital is singly filled. So I need to put this 2 electrons. I will be putting one in this and one in this because they possess the same energy. So this is actually my electronic configuration for O2 molecule. Let's write it for O2 positive now. So the first step, as I told you, is to count the total number of electrons. So let's count first. Total of 8 electrons, 2 atoms, again 16, but here what we get to see, a positive charge. Positive charge means the number of positive charge corresponds that you need to subtract this much electrons from the total electrons. So it has 1 positive, so we will be subtracting 1 electron from it. So I will subtract 1 electron, and after that how many electrons I am left with? 15. So I need to write the electronic configuration for the 15 electrons. So again I will write it, sigma 1 is square, sigma star 1 is square, sigma 2 is square, sigma star 2 is square. Again we are following the writing for O2, so again the first order is being followed. Sigma 2pz square, pi 2px is equal to pi 2py. Just let's count again, 2, 4, 6, 8, 10. We are left with 5. So we can fill 2 and 2, and now we have only 1 electron left. So now how you, like in which orbital you will be filling 1 electron? Obviously in the first one. So again let's check it out. 2, 4, 6, 8, 10, 11, 12, 13, 14 and 15. So this is my electronic configuration for this ion. So likewise you will be writing the electronic configuration for different molecules, and the molecule possessing a charge also. The only thing what you have to keep in mind, that the order of the energies which has to be followed, like the order in which you have to fill the shell, it will remain same, and you have to keep in mind that for O2 in neon 2 and F2 you follow this order, but for the rest of them what happens, the energy of sigma 2pz actually increase, so it is being filled after pi 2px and pi 2py. Otherwise you can fill in this way, right? So this is how you are going to write the electronic configuration. So now as we all know that how to now write the electronic configuration, let's make an energy level diagram for it, right? So just look at the board, with the energy level diagram you will get to know many more properties. So just we'll continue this, so just look at the board.